Hello everyone, my name is Ali Behrouz and today I'm going to present our work on anomaly detection in human brain via inductive learning on temporal multiplex network. Brain networks are one of the powerful paradigm to model brain activity or brain structure via graphs. In brain networks, each node is a brain region and we connect two nodes by an edge if they are somehow associated with each other. For example, in a brain network obtained from functional MRI, we model that as a graph where nodes are brain regions and each edge measures a statistical correlation between the functionality of its endpoint. Similarly, if we have a structural MRI, each edge measures the fiber between its endpoint. However, one of the main limitations of most existing studies is to use a single modality of neuroimaging data or neuroimaging data of an individual person. The main reason for that is a brain network generated from an individual or neuroimaging modality can be noisy, incomplete, or even irrelevant to the disease that we want to study. To this end, we suggest using multiplex brain networks where each view of the graph shows a brain network of an individual person or image modality or signal bandwidths. Here is the overview of Admire, which automatically detects abnormal connection in the brain network of people living with a specific disease or disorder. And the main intuition of Admire is to use causal anonymous box to extract the causality of an existence of an edge. So we first designed two types of walks in multiplex brain network. First is interview walks, where the walker walks across different views to capture the causal relationship between different views. And second is intraview walks, which are simple random walks that walker can only walk over one specific view. After sampling some interview and intraview walks, we anonymize each walk to hide the node and view identity. And the main reason for that is to allow the model to learn the pattern instead of overfitting the model identity. Next, we use simple multilayer perceptron to encode hidden nodes and view identities, as well as Fourier features to encode the time. At the end, we train our model using contrastive learning approach in an unsupervised manner based on the obtained encodings. In our experimental studies, we focus on attention hyperactivity disorder, autism disorder, and Parkinson's disease. And in the ADHD data, each view is a brain network of a person obtained from fMRI. In the ASD, each view is a brain network obtained from functional MRI with a specific signal bandwidth. And in the PD data, the first view corresponds to the functional MRI, and the second corresponds to the structural MRI. We trained our model on the typically developed group while testing on the condition group. Admire finds abnormal brain activity in the condition group that surprisingly are consistent with the previous studies. Most specifically, in the ADHD group, it finds anomalies in the frontal pole and right superior parietal lobule. In the ASD, it found anomalies in a superior temporal gyrus. And finally, in the PD group, it found anomalous connections in the posterior cingulate. Thank you so much for listening. Here is the code of our approach.